light emitting diode, LED, or light emitting diode. LED means light emitting diode. LED or light emitting diode. This is the symbol of PN junction diode, or this is a PN junction diode, and it will be forward biased. Which side is P side? Obviously, this side is P side and this side is N region or N side. And forward biased means positive terminal of the battery is connected to P region of the semiconductor, PN junction diode. And this is the external battery. External battery has the EMF positive terminal and negative terminal. And this PN junction diode is connected to a load resistance. If we the load resistance RL is not connected, in that case the battery will send the current to the junction, and the junction will be damaged, because in that case large current will be flowing. And if we connect RL or load resistance, in that case current will decrease and the PN junction diode will act, and this is known as load resistance. Purpose is to use the load resistance is what? If we connect load resistance, total current of the circuit decreases, and in this case EMF of the battery is V. EMF of the battery is V, and this diode is will be under a circle. We can draw a circle. This is LED, obviously. PN junction diode means totally it is called LED. In that case, light will be emitted from the N region of the PN junction diode. Light will be emitted from the N region of the PN junction diode. At a certain voltage, electromagnetic wave, that is light, will be radiated from the N region of the forward biased PN junction diode. And this is what the radiation, and this is known as light, or which indicates that light is emitted from forward biased PN junction diode. We can denote the direction of current, forward current I. I is the forward current which will be flowing in this circuit. Right, due to, main concept is what? Due to recombination of holes and conduction electrons. Holes and electrons means conduction electrons. Conduction electrons of forward biased PN junction diode, forward biased PN junction diode, comma, energy is released. Energy is released at the junction, important, from which portion? Obviously at the junction. Energy is released at the junction of the diode. That means due to recombination of holes and conduction electrons of forward biased PN junction diode, energy is released at the junction of diode. That is why this forward biased PN junction diode is called LED. And in another way, that means if we draw a forward biased PN junction diode, this is P region and other portion is N region. This is P region and N region. And LED means obviously it is forward biased PN junction diode, means P region is connected to positive terminal of the battery, N region is connected to negative terminal of the battery. And we can denote the depletion layer. In forward biased PN junction diode, depletion layer becomes thin. In P region there should be immobile negative ions. In N region, in depletion layer there should be immobile positive ions, and this region is called depletion layer. And in P region obviously holes are majority charge carriers which will cross the junction, and this is conduction electrons. And in N region, conduction electrons are majority charge carriers and holes are minority charge carriers. And under the action of positive terminal of the battery, holes will be repelled towards the junction, and conduction electrons will be attracted towards away from the junction and will be attracted by the positive terminal of the battery. Similarly, in N region, conduction electrons will be repelled by negative terminal of the battery and they will be repelled towards the junction. And this is hole or holes, and this dot means conduction electrons. In this case, when hole migrate through the junction and recombine with this electron, that means if this hole migrate the junction and recombine or neutralize this this conduction electron, in that case obviously conduction electrons, similarly conduction electron, we can assume that conduction electron will cross the junction and recombine with the hole. That means hole exists in valence band and conduction electron exists in conduction band or in higher energy band. In that case, due to this recombination or due to movement of conduction electrons from conduction band to valence band, from higher energy level to lower energy level, from the junction what is radiated? From the junction, light is radiated, or an electromagnetic wave is radiated, because conduction electron travels from conduction band to valence band or travels from N region to P region to recombine or to neutralize the holes. And in terms of energy band diagram, this is conduction band, which is conduction band. This is conduction band or CB. This is conduction band or CB. We can draw the valence band, which is actually a branch of lower energy levels. In valence band, we have a number of valence electrons. This dot means valence electrons which are bound to silicon nucleus of the semiconductor with covalent bond, and here we have hole, and we have conduction electrons. and this energy gap is Eg. In this case, obviously conduction electrons migrate from which region to which region? Conduction electrons migrate from which region to which region? N to P region. That means conduction electrons migrate from jumps from which band to which band? Conduction band to valence band. Here this dot in valence band is what? What type of electrons? Valence electrons. But the dot in p-n junction diode are actually the conduction electrons. And this dot is what? Conduction electrons. In this case, conduction electrons migrate nearer to what? Migrates nearer to holes. That means what we can say? Conduction electrons jumps from conduction band to valence band to neutralize the hole. And we know that in this case, conduction electrons are traveling from higher energy level to lower energy level. As a result, we know that according to Bohr's theory, if conduction electrons jump from conduction band to valence band, what is emitted? Obviously, light is emitted.
Photons are emitted.
Photons are emitted. Now, is it clear or not?
Clear.
Clear. And this conduction electrons, why does this conduction electron migrate from conduction band to valence band or N region to P region? Due to the voltage or EMF of the external battery. This is the external battery, and this external EMF of the external battery repels the holes towards the junction from N region to P region to N region, and negative terminal of the external battery repels the conduction electrons in N region towards the junction. Actually, what happens when these conduction electrons migrate or cross the junction from N region to P region, and it recombine or neutralize this positive hole, in that case light will be emitted. Light will be emitted from what? P region or N region or from the junction? From the junction.
From the junction.
That is called LED. Clear?
Clear.
Next. এগুলো কনসেপ্ট
মানে এলইডি তে যেটা জ্বলতে দেখি আমরা সেটাই জাংশনটা।
হ্যাঁ, মানে লাইট ওইটা দেখ একটা এলইডি তে ওই তো মানে লাইট উইল বি এমিটেড ফ্রম দ্য জাংশন অফ পিন জাংশন ডায়োড। মানে if we apply a particular voltage by using external battery or external electric source to a PN junction diode such that PN junction diode is forward biased, in that case few conduction electrons will travel from higher energy level, that is conduction band, to lower energy level, that is valence band. And we know that according to Bohr's theory, when conduction electrons travel from higher energy level to lower energy level, it will radiate energy as light.